So today we are going to be solving two integration questions. In the first question we have to find the integration of cot square 2x minus 1 divided by 2 times cot 2x minus the product of cos 8x and cot 4x. And in the second question you have to find the integration of 1 plus tangent of x into tangent of x plus a. And also both of this integration are to be found with respect to x. Now both of these questions were interesting and have a different approach to solve them. So I thought to make a video in which both of these questions are combined and there is no other reason, okay? So now let us start the solution part of the video by solving the first integral. So I'll just label it as a capital I, and this thing equals to integration of this particular thing. So I'm just writing it down over here. So now as per the question we have to find the integration of this thing. So what I can see is that in this particular integration we have two terms. This is the first term and this is the second term. The second term is looking normal, it's just a multiplication of two trigonometric ratios with the angle 8x and 4x respectively. But the first term is looking a bit more complicated. I can see we can further simplify this thing. So the first thing that I will do in order to simplify this first term is I will break down cot of 2x as equals to cos of 2x divided by sine of 2x. So now let us replace this thing in the integration. So now the integration will look like integration of cos of 2x upon sine of 2x the complete square. This is in place of cot square 2x minus 1 divided by 2 times cos of 2x divided by sine of 2x. Now this thing is the first term. Now we have to subtract the second term from this. So I'm just removing this one from here. And the second term we have is cos of 8x into cot of 4x dx. Now let us simplify the thing present in the numerator. So it can be just simplified by opening the square, taking the LCM in order to get cos 2x the complete square minus sine 2x the complete square, and this thing divided by sine 2x the complete square. Now what I can say is that a fraction is present in the numerator and one more fraction is present in the denominator. So this thing can be easily simplified. We all know this particular rule that a upon b the complete divided by c upon d. So this can be written as a into d divided by b into c, okay? So the same thing we can do over here. Therefore the first term will now look like cos of 2x the complete square minus sine of 2x the complete square, this thing multiplied with sine of 2x, and all of this divided by this particular denominator as it is, that is sine of 2x the complete square, and this thing multiplied by this numerator that is going to be 2 times cos of 2x, okay? Now I can see that this sine square 2x is present in the denominator, sine 2x is in the numerator. They both will simplify each other at the end, giving sine 2x in the denominator, okay? Now minus this term as it is, that is cos of 8x into cotangent of 4 times x, and at the end dx. Now I can see one more identity present over here, that is in the numerator. Recall the identity for cos of 2 times a. The identity was cos of 2 times a is equals to cos square a minus sine square a. Now in this particular identity, if I just replace a as equals to 2 times x, I can get cos of 4 times x equals to cos square of 2 times x minus sine square of 2 times x. So we can see in the numerator we have the same right hand side of this equation, and the right hand side is already equals to cos 4x. Therefore the numerator over here can be replaced with that value, and it is going to be cos of 4 times x divided by, in the denominator we are left with this thing, that is 2 times sine of 2x into cos of 2x. Now we will again take help of a trigonometric identity, and this time the identity is of sine of 2 times a, that is 2 times sine a into cos of a. This is the identity for sine of 2 times a. So the same identity I can see over here. All I need to do is I need to replace a as equals to 2 times x. So I will get the value of sine of 4 times x equals to 2 times sine 2x into cos 2x. So you can see this term over here is just present in the denominator, and as per the identity that term is having a value sine 4x. So this thing over here can be just replaced with sine of 4 times x and minus the second term as it is, that is cos of 8 times x into cot of 4 times x, and at the end dx, okay? Now this thing over here is simply cotangent of 4 times x, that is cot of 4 times x. This is the basic of the trigonometry. Now I can see something very nice over here, and that is from first and the second term I can simply take cot of 4 times x common. You can look carefully that the first term that was originally given just simplified, and at the end we are left with cot of 4x. Okay. Now 1 minus cos of 8x just getting multiplied with cot 4x after taking common, and at the end dx. Now we can just simplify this thing over here, and for that we have to look forward to another identity for cos of 2 times theta. So we have that cos of 2 times a or theta. Now as per the identity, the breakdown of cos 2 times a is simply 1 minus 2 times sine square a. If you remember, we just previously used cos of 2 times a equals to cos square a minus sine square a. We previously used this thing in the solution. So in the same thing over here, cos square a can be replaced as 1 minus sine square a using the universal identity cos square a plus sine square a is equals to 1. So when we do so, this thing will simply turn out to be 1 minus 2 times sine square a. So this above identity is the same thing, we have just done a little modification. Okay. So now we have this particular identity, and in this I can simply replace a as equals to 4 times x. So I will get the value of cos of 8 times x equals to 1 minus 2 times sine square 4 times x. And now if I shift this particular term on the other side, I will get the value of 2 times sine square 4 times x equals to 1 minus cos of 8 times x. So you can see in this particular bracket we have the same term 1 minus cos of 8 times x. So that can be just replaced as 2 times sine square 4 times x. So on doing so, this integration was originally taken as I will now turn out to be integration of. Now this cot of 4 times x, I will just again put it back as cos of 4 times x divided by sine of 4 times x. Okay. Now this thing multiplied with this particular term, we have got its value as 2 times sine square 4x. So now putting that value over here at the end dx. Now I can see that sine square 4 times x divided by sine of 4 times x will simply give me sine of 4x in the numerator. Now again we can see 2 times sine of theta into cos of theta will give me sine of 2 theta. This is the identity. So now in this particular identity, if I just replace theta as equals to 4 times x, I will get sine of 8x equals to 2 times sine 4x into cos 4x. So we can see this particular term is present over here, and it has a value that is sine 8x. So we can replace that value over here. So finally the value of I will turn out to be integration of sine of 8x dx. Okay. Now integration of this thing is very simple. All we need to do is a simple substitution for 8 times x, and after doing some simple calculation, the value of I will turn out to be negative cos of 8 times x divided by 8 plus the constant c, and this is the value of the first integration that is asked. Now let us move on to the solution of second one, but before, let us see how much we did in this one. So this all thing we did in order to get the integration value of the first question. Okay. Now let us see how can we integrate the second question. So here is the second question, and this time I will take it as phi. Okay. So this time we have to integrate 1 plus tangent of x into tangent of x plus a. Now remember my words that whenever tangent is there in the integration, first of all look for its identity and then for the simplification work, because if you remember that most famous question of that is integration of tangent of 3x into tangent of 2x into tangent of x dx. At first when we look at this, we can see that these terms are just in multiplication, and if we try to simplify this thing by putting this value as sine and cos, this thing is going to be very ridiculous. But if we break down this particular whole term into something else using the identity of tangent, we can simplify this thing very easily. For example, in this one, by using the identity of tangent, this thing can be written as tangent of 3x minus tangent of 2x minus tangent of x. This and this are the same thing. This can be easily proved using the trigonometric identity of tangent of a plus b. Using this identity, we can prove this relation. So now as these two values are same, integration of this thing would be same as the integration of this one. And the integration of this second thing is very simple. Integration of tangent of 3x minus the integration of tangent of 2x minus the integration of tangent of x, and the answer will be very simple. But wait a minute, do you remember the integration of tangent of a? If not, let me tell you that integration of tangent of a dA is equals to natural log of sec of a plus the constant c. Okay, if you remember well and good, and if you don't, keep this thing in mind because we are going to use this thing in the solution of this one. Okay, now as I told you, if there is only tangent present in the integration, first of all think that is there any kind of identity related to trigonometry or just to the ratio of tangent using which we can find another value to this one. So for some of the question you can get a nice value, for some you may don't get a value, and for some you can get a complex value. It's upon you if you want to go forward with that method or if you want to just simplify the given integral and solve it. It's just dependent upon the question. Okay, so in this particular question I am going to use the substitution, that is using a trigonometric identity or just the identity of the ratio tangent in order to find other value of this particular term. So what I will simply do is, first of all, I will just write down the identity of tangent of x plus y, not x plus y because that's already present in the question, let it be alpha plus theta. So tangent of alpha plus theta is equals to tangent of alpha plus tangent of theta divided by 1 minus tangent of alpha into tangent of theta. Now what I can see over here is that something like this way of pattern is present in the denominator, but we have a negative sign, so no need. We have the other identity of tangent of alpha minus theta, and in that this thing can be adjustable. So the identity for tangent of alpha minus theta is tangent of alpha minus tangent of theta divided by 1 plus tangent of alpha into tangent of theta. So now what I can see is that this kind of pattern is present in this one. Now the second thing to be noted over here is that we are trying to find the value of this thing in something else. So if I just look forward with this particular pattern by just replacing alpha as equals to x plus a and the value of theta as x. So now using this substitution, the identity will look like tangent of now alpha minus theta, therefore x plus a minus x, and this thing at the end will give me only a. So you can see over here we have tangent of a, and as a is a constant, tangent of a will also be treated as a constant. This thing equals to, I will bring that whole term over here and this one over there. Okay, so now we have this particular equation that is absolutely true and correct, and in this we have the value for 1 plus tangent of x plus a into tangent of x. So the original integration that we have taken as phi equals to integration of this particular term. So integration of this term would be same as the integration of this term, as this both things are equal. So instead of finding the integration of this one, we will find the integration of this, and it will be same as the integration of this one. Well, simple and nice. So now putting this thing over here, that is going to be tangent of x plus a minus tangent of x divided by tangent of a. This thing is a constant, remember that, and at the end dx. Now as tangent of a is a constant, it can be taken out, so we will have 1 upon tangent of a, that is ultimately cot of a, into integration of this minus the integration of this. So integration of tangent of x plus a dx minus the integration of tangent of x dx, and we have to even put the brackets because cot of a is multiplied with both the terms. Now integration of this thing is very simple, as I showed you. The identity for integration of tangent a with respect to a is going to be natural log of sec of a plus the constant c. So by doing that simple thing, we will have the value over here as cot of a multiplied with integration of this thing would be natural log of sec of x plus a, the modulus close, minus the integration of this one would simply be natural log of sec of x, the modulus close, the bracket close, and plus the constant c. Now this thing over here can be simplified using the identity of natural log of a minus natural log of b equals to natural log of a upon b. So finally the value of phi that we have taken as the integration would be equals to cot of a multiplied with natural log of sec of x plus a divided by sec of x, and at the end plus the constant c, and this is the answer to the second integral. So these were my ways to solve these two problems. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.